First, let's learn how to identify limiting reagent problem. In this particular case, the word limiting reagent is given, that's one clue. Usually also two reactants will be given, in this case a 2-gram sample of ammonia with 4 grams of oxygen, so two reagents. The words limiting reagent, these are all keywords that you should be looking for to see what you're looking at. Now, as with any problem, the first thing that we're going to do is write and balance an equation. So the equation we have is 2 grams of ammonia. Ammonia is NH3. It reacts with oxygen. Remember, oxygen is not O, it's O2. It produces nitrogen monoxide, covalent compound, and then water. Go ahead, balance this. This would be 4, 5, 4, and 6. Next we have 2 grams of ammonia. We also have 4 grams of oxygen. Let's review the definition of limiting reagent. It is the one that is exhausted in the reaction or used up in the reaction. Also, the second definition is it limits or lowers the amount of product produced. That second definition is the one that we're going to utilize to solve this particular problem. So we have 2 grams of ammonia. We're going to convert the 2 grams of ammonia to moles. So 1 mole of ammonia, it weighs about 17 grams. Grams gets cancelled. That is to convert to moles. Next, we need to figure out how much product. So you can either choose NO or you can choose H2O. In the first case, I'm going to choose NO. 4 NO produces 4 NH3. And then 30 grams of NO produces 1 mole of NO. So what I'm doing here is I'm looking at the equation and I'm predicting moles of NO. And here I'm looking at the moles of NO to grams of NO conversion. You can do a similar thing for the O2, so you can take the 4 grams of O2 and convert it to moles. Each O2 weighs 32 grams. Figure out how many NOs will be produced, so 4 NOs for every 5 O2. So look at the equation, 4 NO, 5 O2. O2 gets cancelled, grams gets cancelled, and now we need to use the molar mass of NO, 30 grams, 1 mole. Mole gets cancelled, and you get an answer of 3 grams of NO. Now we need to compare this number to this number. Which one is smaller? Smaller. Taking 2 grams of ammonia produces 3.53 grams of NO. Taking 4 grams of O2 produces only 3 grams of NO. So in this particular reaction, if there was enough O2, if there was a little bit more, then you would get 3.53 NO. But there wasn't, and therefore you got only 3 grams. So which is the limiting reagent? The one that produces the least amount of product is the limiting reagent. So O2 is the limiting reagent, which means NH3 is the excess reagent. So once again, NH3 produces more product, therefore it is the excess reagent. O2 produces the least amount of product, therefore it is the limiting reagent. The next question is, we know that NH3 is the excess reagent. After the reaction, how much of NH3 is left behind? Remember, all of the O2 is used up. So we have 4 grams of O2. That is, we have these many moles of O2. And these many moles of O2 react with NH3 in the ratio 4 NH3 to 5 O2. And let's convert that to grams of NH3. And you get 1.70 grams of NH3. So for every 4 grams of O2, only 1.7 grams of NH3 react. We have 2 grams. Since we have 2 grams, the amount of excess that we have is 2 grams minus 1.7. We have 0.3 grams of ammonia after the reaction remaining. And that's your summary. You write a reaction, you balance it, you figure out how much product is formed by each reactant or reagent. Whichever produces the smaller amount of product is the limiting reagent, followed by the excess reagent calculation, which is you take your limiting reagent and figure out how much of the excess it would have used up and subtract the two, you'll find out how much is remaining.